NETL's Pittsburgh facility is located in the Brewston Research Center, part of a campus that includes the Centers for Disease Control and Prevention, the National Institute for Occupational Safety and Health, and the U.S. Department of Labor's Mine Safety and Health Administration. The site is unique among NETL's facilities. For more than a century, researchers at the Pittsburgh site have worked to make crucial discoveries in energy-related fields. One of the site's early contributions occurred on October 30th, 1911, when researchers intentionally set off an explosion in an experimental mine to prove that coal dust, regardless of the presence of methane, can cause a deadly blast. It was a watershed event that enhanced safety and saved countless lives. Through the decades, that same commitment to groundbreaking research has continued at NETL's Pittsburgh campus. Today, the site's scientists, engineers, and other professionals work to drive innovation and deliver solutions for an environmentally sustainable and prosperous energy future for the American people. NETL oversees an expansive portfolio of research activities. These efforts include revolutionary research to produce, deliver, and store hydrogen so it can be widely used as a clean-burning fuel within a decade, as well as the completion of life cycle analyses to evaluate the environmental, economic, and social attributes of energy systems. The site has also been a leader in the use of high-performance computing. This technical expertise has permitted researchers to simulate experiments at significantly lower costs to deepen their understanding of combustion processes, the efficiency of gas turbines operating at power plants, and many other topics. Chief among priorities for NETL are efforts to scale up technologies to capture and permanently and safely store carbon dioxide, CO2, in the geologic subsurface, or use captured CO2 as a feedstock to make value-added products. Through its intramural research and in partnership with industry, research universities, and other national labs, NETL is at the forefront of developing and supporting technologies needed to reduce emissions of greenhouse gas and reach U.S. goals calling for a 100% carbon emission-free electricity sector by 2035 and a net zero carbon economy by 2050. While point source carbon capture from concentrated point sources is a near-term priority, most climate models predict that to avoid the most damaging effects of climate change, a large amount of carbon will need to be removed directly from the atmosphere. Development of the Direct Air Capture Center at the Pittsburgh campus represents a major step to remove the buildup of CO2 in the atmosphere and decarbonize transportation and other sectors of the economy. It will also accelerate the commercialization of direct air capture technologies and provide developers with the ability to test concepts over a range of conditions. To achieve deep decarbonization, NETL research teams also oversee the development of CO2 capture media such as solvents, sorbents, and membranes. These teams rely on computational methods coupled with NETL's world-class computer capabilities to screen the performance of these materials. To date, researchers at NETL have used computational modeling to rapidly screen over 1 million possible types of membranes to estimate both their CO2 capture performance and how much the capture process would add to the cost of electricity. To address concerns about the permanence of CO2 in geologic formations, NETL researchers use pressure vessels, computer analytics, and machine learning to simulate subsurface pressure and temperatures. By studying carbon sequestration through computer modeling and under controlled conditions in the laboratory, researchers gain insights to predict the behavior of formations undergoing CO2 injection. The lab is turning the tables on CO2 by utilizing it as a chemical feedstock. Researchers are recycling CO2 captured from point sources in the atmosphere into chemicals to manufacture fuels, polymers, and fertilizer. Novel catalysts developed at NETL have opened new doors to complete the CO2 conversion process. As the nation shifts to clean energy, researchers at NETL are taking steps to ensure regions that produce fossil resources and energy are not left behind. The site is refining processes to use opportunistic carbon resources to produce carbon fiber composites, carbon additives for improved construction materials, and carbon nanomaterials. Researchers are also working to extract critical minerals, which are needed to manufacture wind turbines, computers, defense system components, and more from acid mine drainage. The United States has more than 2 million active, abandoned, or repurposed wells, a massive oil and natural gas pipeline network, and related infrastructure that annually emit approximately 8 million tons of methane, a potent greenhouse gas. NETL experts are using atmospheric sensing equipment and technology attached to satellites or manned and unmanned aircraft to locate these methane sources and quantify the levels of methane they emit. More than 100 years after our Big Bang in an experimental mine, NETL's research at the Pittsburgh campus continues to deliver clean, affordable, and reliable energy. Thank you.